Okay, so in my previous video, I have discussed about the procedure or working rule for testing of hypothesis. Now let's see a problem on testing of hypothesis. That is, in a random sample of 60 workers, the average time taken by them to get to work is 33.8 minutes and standard deviation is given to be 6.1. Can we reject the null hypothesis mu is equal to 32.6 in favor of alternate hypothesis as alpha is equal to 0.025 level of significance? See, how do I do it? First of all, whenever you are doing a problem on testing of hypothesis, jot down the data that's been given to me, guys. About the population, it's been given to me in the question, that is mu is equal to the mean of the population is given to me as 32.6 minutes. From this population, a sample is being drawn. The size of the sample, how many workers are considered? That is called the size of the sample, 60. The small n value is 60. X bar, the mean of the sample is denoted by X bar, which is 33.8. Okay, of course, standard deviation of the sample is also being given, denoted by smallest. If standard deviation is not being given, sigma will be given, which is the standard deviation of the population. Any one of them would be given. So always make it a point to write what's the data about the population and data about the sample. This way of pictorial notation would be fine. Now, the first step in testing of hypothesis, as all of you know, is setting H naught. H naught is the null hypothesis. Now, whenever I'm setting H naught, I don't have the freedom to set H naught in any and every way I like. Always population data is the standard data. Sample data is a random data. So always my H naught is set in terms of the population only. That too, whatever statement is being given to me, accordingly only I will set my H naught. What has been given to me about regarding the population mean is mu is equal to 32.6. Now, alternate hypothesis should be contradicting the null hypothesis. Okay, as the definition goes in my previous video, do check the previous video for certain terminology in testing of hypothesis. So, alternate hypothesis is contradicting to null hypothesis. Now, contradicting to equal to, I'll be having three things. One is not equal to. Okay, one can be greater than, one can be less than. Now, usually students have this doubt that when should I choose greater than, when should I choose less than? Okay, because depending on that, I'll be having right-tailed or left-tailed, or a not equal to condition would give me a two-tailed test. Okay, now please look at the mean of the sample, guys. It is 33.8. Mean of the population is 32.6. Mean of the sample is suggesting me that mu can be greater than 32.6. So I'll be setting my alternate hypothesis to be mu greater than 32.6 only. Again, I'm stressing this point. What that is always make it a point to set your H naught and HA only in terms of the data given to me, in terms of the population and not the sample, because sample is random. Okay, once I have set my H naught and HA, of course, if it is two-tailed, it will be given clearly in the question, yes or no, true or false, high or low kind of things, where you will directly write not equal to for HA. Okay. Yeah. After H naught and HA, whatever are being given to me, you will jot the data. Alpha is given to me as 0.025. Okay. Let's draw the Z distribution curve, guys, which is, okay, which is a bell-shaped one. Now, alpha, that is what? The rejection region is 0.025. So what will this value be? 0.475 will be this value. Okay. Now, what will I do? I look at the Z distribution table for the area from 0 to 0.475 in the normal distribution table. Wherever the area is 0.475, that would be my Z value. Okay. 0.475 value would be, I'm just checking the table, 0.475 value would be at 2. 750. It is 1.96. Okay, this Z value would be, Z alpha, it would be what? 1.96 means what? 0.025. Just see here, 0.475, 0.025. Add both of them, 0. 7 plus 2 is 9, plus 1 would be 10 again. 4 plus 1 would be 5.5. So in total, right half area is 0.5. So that value of Z, which is separating rejection region from acceptance region. This is RR, this is AR, guys. From acceptance region would be my Z alpha. Okay, Z alpha is 1.96. Now, why I have taken Z also, I should specify N is equal to 60. The sample size is greater than 30. So I'll be going with a Z test or Z statistic. Okay, what's the formula for Z? Z is equal to X bar minus mu by sigma by root n if sigma value is available. Otherwise, it is X bar minus mu by S by root n. Okay, what is X bar? 33.8. 32.6 is mu. What is S given to me as a 6.1? N is given to me as a 60. It would be under root 60. Guys, okay, see this value. What I'll be getting is 1.5238 is the value that I'll be getting. You can calculate and please check using a calculator. Okay, now what I will tell you is, one more thing, one more suggestion here. I should be writing what? It is a right-tailed test. That means what? Right-tailed test means what? My rejection region is there in the right side. If it's a left-tailed, rejection is on the left side. Okay. So right-tailed test I will be writing. A right-tailed test means what? What I should say? This I will call it to be Z calculator or Z cal value. I'll write a statement here. If Z cal greater than Z tab, what happens? Z tab is what, or Z alpha? Z tab or Z alpha, guys. Z alpha is 1.96. Any value above 1.96 will fall in the rejection region. So if Z cal greater than Z tab, the value falls in rejection region. The value falls in rejection region. Rejection region. Hence, what we'll do? Hence, we reject H0 and accept HA or H1, whatever. Okay. So, what's the value that I have got? Z cal value, I have got it to be 1.5238, which is less than 1.96. So, what should I do? I should accept H0. What that is the mean time, average time or mean time of the workers is, mean time of workers, mu is equal to 32.6 and not greater than 32.6 is how I will conclude. This is how you will do a right tail test question, guys. I'll tell you in the next video how to do a left tail test as well and two tail test. Okay, right.